Hi, in this tutorial I will give you some example about a logic gate as we as in our course on digital electronics. Okay, for what is a logic or digital logic gate? As you know, digital logic gate is an electronic circuit which makes logical decisions based on the combinations of digital signal presents on its inputs. Okay, so you can have a logic gate with a lot of input or 1, 2, 3, or 4, etc. A lot of input. But in this tutorial, we present a logic gate with 2 inputs. The first logic gate I present is the AND gate. Okay, this is the AND gate. What is symbol of the AND gate? The AND gate is like this. When we draw an AND gate, okay, it's like this. 2 inputs is A and B, and this we have output is Q. Okay, and this is what is inside. This is TTL family. So the meaning of TTL is the transistor logic gate. Okay, so in this AND gate we use 2 transistors, and this is circuit of the AND gate. You can see also the truth table. This is a truth table. Okay, the define of the AND gate is that if both A and B are true, so then Q is true. You see, if both A and B are true, then Q is true. Or in other words, you can say that if A equal 1, B equal 1, the output equal 1 for this gate. Okay, I will explain some how does it work. Some explanations of this circuit. For example, for the case of A equal 1, B equal 1, you can see that if A equal 1, okay, and B equal 1, 2 transistors is in series. So the transistor T1, A equal 1, meaning this level of voltage is high, and this level of voltage at B is high. So T open, you see, okay, the transistor T1 is open, transistor T2 is open. In this case, you see that we have a voltage. You can measure a voltage at the output Q. That's why Q is A equal 1, B equal 1. So we have a Q equal 1 because both of transistor is open. Okay, both of transistor are open. And we can consider another case. For example, A equals 0 or B equals 0. What happened? If A equals 0, okay, meaning the voltage at A is low, the voltage at B is low. So the T1, transistor T1 is closed or cut off. T1 cut off also. So we have no current from the VCC go to the key, so go to the output point, meaning the output at Q. We have the voltage at Q equals 0 or the Q equals 0. Okay, this is this step. Okay, this is the AND gate. The next one is the OR gate. So OR gate is the function of OR gate is this Q equal A plus B. And this is symbol of the OR gate. You can see the symbol of OR gate in the circuit. We have the OR gate like this. Okay, A, B, and this is the Q. So the definition of the OR gate is if either A or B is true, then Q is true. Okay, if either A or B is true, then Q is true. You can see in this truth table. Okay. For example, I will in this circuit, you can see that both of two transistor is in parallel. Okay, in parallel to transistor. I can consider an example for A equals 0, B equals 0, for example. You can see that what happened. A equal 0, meaning this transistor is closed. Okay. B equals 0, meaning low voltage is here at the base, and this transistor is closed. So both the transistor is closed, so the output, you can see we haven't got the current. We can go through the VCC to the output. So at the output, at this point, at the Q, we have no voltage. So Q equal 0. Okay, exactly like this states in the truth table. Now A equal 1, B equal 1. What happened? Okay, A equal 1 meaning this transistor is open, or this transistor will open also. Both of transistor is open. Both of transistor are open. Sorry. So at the output we have the current, or the output we have a voltage. We can measure a voltage at this point. So Q equal 1. Okay. So this is this. Okay. So that's it OR gate. The next is the NOT gate. The symbol of NOT gate is this. Okay. So if we have A here, so the output is not A. The definition of NOT gate is if A is not true, so the output is true, and vice versa. If A is not true, if input is not true, so output is true. Okay, and this is the circuit of the NOT gate. You can see that, for example, if I give a high voltage for A, meaning the transistor will open. So in this case, the current can go through the VCC to the ground. Okay, so at this point, at the output point, the Q will be 0, meaning A equal 1. So Q equal 0. Okay, or if we have A equal 0, the output Q will be 1. Okay, this is a NOT gate because of this circuit. The NAND gate, okay, the NAND gate, okay, you can see this NAND gate. The NAND gate symbol, NAND gate is like this. Similar with the AND gate, but we have a small circle at the output. A, B, and this is Q. Okay. The definition of NAND gate is that if both A and B are true, then Q is not true. Okay. If both A and B are true, then Q is not true. That is NAND gate. You can see. You can consider one example. For example, I have A equal 1, B equal 1. So what happened? You can see that A equal 1 at this point, okay. A equal 1 meaning this T1 will be open. B equal 1, the T2 will be open also. So if both of transistors are open, the current will go through the VCC to the ground. Okay, and at the output, we can measure at the output voltage. We have a value of 0. Q equals 0. No voltage. Okay, this is NAND gate. You can compare that. So NAND gate is similar to the AND gate, but at the output, you can see the AND gate. Okay, this is AND gate, and you compare with the NAND gate. What happened? What's different? You see that at the output of the NAND gate is the output point is higher than the transistor T1, and this at the end gate output point is lower than the transistor T2. Okay, that is the difference between the AND gate and NAND gate. Okay, the last one I want to show you is the NOR gate. Okay, it is a NAND gate and this NOR gate. NOR gate is symbol of NOR gate is this. Okay, similar with the OR gate but with a small circle. So this is the A, this is the B, this is the Q. And the definition of NOR gate is if both A and B are not true, then the output is true. Okay, this case, if both A and B are not true, so the output is true. Okay, you can consider that, for example, A equals 0, B equals 0. So what happened? You see that two transistors is in parallel. So if A equals 0, B equals 0, meaning the transistor will close. T1 is closed, T2 is closed. So the current will stuck here. Okay, the current cannot go to the ground, and that's the output. We have a value of voltage, meaning a high voltage. So Q equal 1. That's why we have these values. Okay, and I can consider another. For example, A equal 1, B equal 1. So what happened? A equal 1, B equal 1. So both the transistors will be open. So of course the current will go through the transistor to the ground, and in that case the Q will be connected to the ground, meaning the Q voltage is very low, or Q equal 0. Okay, so there are some example about the logic gate. Thank you very much for listening. Goodbye.